All right, ladies and gentlemen, so today we're going to get into a little bit more in depth into this idea of what it means to be similar and similarity. So in the diagram below, right, we have points R and S have been dilated from center O using a scale factor of K equals 3. So please outline that. So if OR is 2.3, so they're saying this little piece right here is 2.3, we want to know what's the length of the big piece. In other words, I give you the pre-image, we're trying to find the image. So in order to do that, we're going to take our 2.3 and we're going to multiply it by 3. So that should give me 6.9 centimeters. All right, that was what we did yesterday. We did it the day before, right? You multiply by your scale factor. Okay, if the length of OS is 3.5, then they're asking us to find the length of OS prime. Oops, sorry. So same idea. We're going to take the length of OS. We're going to multiply by that scale factor and check my math. Hopefully I did that correctly. 10.5 centimeters. Okay, so far so good. Now connect the point R to the point S. And the point R prime to S prime. So by doing that, what we have now done, I'm going to erase my little lines up here. Is we now have created two different triangles, right? We have our pre-image triangle, ROS, and then we have our image triangle, OR prime, S prime. So let's see here. We did that. Done. What do you know about line RS and excuse me, and R prime, S prime? Well, we know a couple of things. We know that R prime, S prime is 3 times as big. We also know that by doing that, we have now created parallel lines. So RS is parallel to R prime, S prime. So what is the relationship between the lengths? We already said that. 3 times as big. Identify pairs of angles that are equal in measure. So this is now what we're going to be thinking about our parallel lines cut by a transversal. Here are our parallel lines. I'm going to do them in red this time. And we have two different transversals. So I'm going to take a look over at this side of the picture first. Okay, so I'm going to just put some numbers in. I'm going to call this 1 and 2, just to make it a little easier. So I know that angle 1 is congruent to angle 2 because they are corresponding. So we're going to be bringing in some of that vocabulary from the last chapter. If I look on the other side, right, here's my parallel lines, here's my other transversal, right, I know that angle 3 and angle 4 are going to be congruent because they are corresponding as well. So when we have these pictures, right, now we're creating these similar triangles. And in these triangles, the sides are going to all have the same scale factor, and the angles are going to have to be congruent. All right, let's see if we can look at another example here. So here's one that's actually done on a graph. So he dilated points B and C from center O. So here is our original. I'm going to outline the original in red. So this time our original is bigger. All right. Then we have our image is going to be up here. Okay. What is the scale factor of K? Show your work. Well, remember, scale factor is always going to be image divided by pre-image. So my image, I'm just going to count. I can pick any of the sides I want, but I'm going to just count down. So my image, pre-image, sorry, pre-image is 1, 2, 3, 4, 5, 6 squares. My image is 1, 2 squares. So that reduces to 1/3, right? So this was a shrink. So we have 1/3. Verify the scale factor with a different set of segments. So now I'm going to use the horizontal ones. So again, I need my my pre-image is 1, 2, 3, 4, 5, 6, 7, 8, 9. That goes on the bottom. My image is 1, 2, 3. That goes on the top. 3/9 also reduces to 1/3. Which segments are parallel? B prime, C prime, and BC. How do you know? Because they're straight across and they're the same distance. Distance apart. All right. Which angles are equal in measure? So again, we have to think about our parallel lines. We're going to have two different transversals. We're going to have the straight up and down transversal, and we're going to have the diagonal transversal. So again, I'm going to put in some numbers just to make life a little easier. So I know that this angle 1 and this angle 2 are congruent. Congruent to angle 2. How do you know? Because they are corresponding angles. I know that angle, again, if I put some numbers in here, angle 3 and angle 4 are congruent because they're corresponding. If the length of OC, so OC is our diagonal line there. If the length of OC is 3.6, what is the length of OC prime? Well, this is my pre-image, and I have to multiply by the scale factor, which we figured out before was 1/3. So that should give us 1.2, oh, it doesn't use units, sorry. So 1.2. All right, how does the perimeter of triangle OBC compare to the perimeter of triangle O prime, B prime, and C prime? Well, now that I know all my numbers, right, so let's do the big triangle first. So we know that this one was 6, this one was 9, and it doesn't really make sense given the numbers that we have, but that's okay. We'll use them anyway. And this one was 3.6, right? So to find the perimeter, I have to add up the sides. So we're going to have 6 plus 9 plus 3.6. And if I do that correctly, I should get 18.6. And then for my little one, right, we have 2. This side was 2, this side was 3, and we just figured out this side is 1.2. I hope I remember that correctly. Yep, okay. So 2 plus 3 plus 1.2 should give me 6.2. So now I'm going to see, is it the same scale factor? So 6.2 over 18.6, which does indeed reduce to 1/3. All right, so, but we want to know, how does it compare, how does the big compare to the little? So OBC is 3 times as big, because they asked us to compare it in a different order. Okay, did the perimeter of the triangle equal KX? Yes. And we already did the work, so I'm not going to explain that again. Okay, so just trying to get into a little bit more detail. Is there another page? Yep, okay. Whew. Mrs. Bowen's homeroom is creating a web page for their school's internet site. They need to reduce a scanned photograph, so it is 720 pixels by 320. They tell us what it is. What is the scale factor of the dilation? So here, this is your original, right, or pre-image, and this is your image. So it doesn't matter which set of numbers you use, Okay, but it's always, oh, I totally screwed that up. I'm sorry. Erase, erase, erase. See, this is what happens when you don't read carefully. This is your pre, this is your image. Sorry about that. Okay, so remember it's always, excuse me, image over pre-image. So I'm going to do the 720 over the 1080. And if I reduce that, which again, you can be using your calculators to help you with this, it reduces to 2/3. So that is your scale factor. Okay, figure DEFG is shown on the coordinate plane below. The figure is dilated from the origin by a scale factor of 3/2. Identify the coordinates of the dilated figure and label it. So I'm going to take each of these points and I'm going to multiply them by 3/2. Now 3/2 is an improper fraction, which means my number should get bigger. All right, so I'm going to start with D. D is over here at -3, 1. So I'm going to multiply each of those by 3/2. So 3 times 3/2 is going to give me -4.5. And 1 times 3/2 is 3/2. So that's going to be D prime. So approximate where it goes. There's D prime. All right, for G, G is at 0.5. So when I multiply it by 3/2, that's still going to give me 0, and 5 times 3/2 is going to give me 7.5. And let's see, that's about right here. So that is G prime. I like doing different colors. F is over here at 6.1. So when I multiply that by 3/2, I'm going to get 9, 3/2. So that's going to be about here. There's F prime. And E is at -1, -1. So when I multiply those, that's going to give me -3/2, -3/2. I think I just wrote over where I need to be, right about here. So my new picture is going to look like that. Okay? So there we go. All right. Any questions? As always, bring them to class and have a good night, guys.